All right, how's that sound? Is that good? All right, cool. We're going to get started. How are we doing, John? Any better? Okay, is this enough?
Yeah, I'm just turning it down because it's like excessively loud.
Okay, yep, that sounds good.
You ready?
Yep, let's do it.
We're good.
Yeah. All right, everybody, welcome back to the second part of our RITSEC, our week 2 meeting for the research segment. So if you guys have not already, please make sure you go to signin.ritsec.club. Make sure you sign in. That way we can get all of the information to our sponsors and make them really happy. On that note, thank you very much to all of our generous sponsors who enable us to make things like Hackathon and all of our competitions happen. We really wouldn't be able to do it without you guys. Oh. Okay, we're good. Oh, no, we're not. Okay, we're going to. Is it this one? Nope. Yup. What is it doing? Can you check the connection? It's still doing it, because look right in the Eaton.
Oh, that's a mouse thing, bro.
No, it's not. The mouse is over here.
Oh. Very cool. Not sure.
The laptop fell asleep. Well, actually, the laptop died.
When it sleeps or goes the powers off, it likes to not work. That's like its favorite thing.
Please hold for technical difficulties. That's what we're giving everybody for competition. That's a complete meme. That would be a funny meme, though.
So now it's not showing up on the screen, which is cool.
Oh, God.
It was just working, which is great.
Yes, you can. You need... This is a Chromebook, yeah. Yeah, this is a legit Chromebook. This is my old laptop. This is from, like, high school. And it's... It was a Chromebook in high school. It was a Chromebook in high school. That's why it wasn't a real laptop.
All right, we're good.
All right, take 2.
All right, all you.
Cool. So, where'd Q go?
Over here.
Q, did you want to talk about this one, or? All right, cool. There you go.
Hello, everybody. So for the CTF, I'm looking for competition architects, or not competition architects, challenge authors, CA, close enough. I'm looking for challenge authors and white team members to help run the CTF and write challenges for it. And I am also looking for RITSEC black team members. If you're interested in doing any of the above, please follow the link. There's a nice Google form to fill out. Any help would be appreciated.
Yeah. So if you guys have been looking for a way to get involved, I would definitely recommend participating on the black team or the white teams for our competitions and stuff. If you've already competed in a competition, blue teaming is going to be one of the best experiences you're ever going to have at RIT. That was also for IRSEC. Yep. Get learned. All right, so UB Lockdown is coming up soon. It is the red team, blue team style competition that University of Buffalo's security team hosts, or security club hosts. That is going to be October-ish? Did we ever find a date for that earlier?
It's near future.
Somebody said it. It's somewhere in October, yeah. So we can send a limited number of teams to UB. I think it's about 12 people, give or take. It's a great first-time competition to get your feet wet if you have never competed in a competition before. It is a first-come, first-served basis, so if you're thinking about signing up, you should definitely do it sooner rather than later. That way you can secure a spot. When? It is October 26th. Part of our red team goes, and we have a bunch of blue teamers that go. So getting there is not going to be an issue. We've got a whole bunch of people that go in carpool. So if you guys are thinking about it, it's definitely a great opportunity, and I would definitely recommend it. Movie night. Coming up next weekend, not the next 2 days, but a week from now, we are going to be watching Swordfish in 1400 on Sunday the 15th. We're going to go, we're going to sit, and we're going to make fun of the movie the whole time and eat a bunch of food and have a really great time. So come join us to watch Swordfish. Matt, are you still here? Yeah.
Hello. So there's during ShmooCon, which is a hacker convention or hacker conference around Washington, D.C., there will be a competition called Hack Fortress, which we have lost for like 3 years in a row. So we're trying to change that around, and all you need to do is know how to play TF2 or want to learn how to play TF2. Just join the workplace group, and we will announce a time to meet soon.
Cool. Thanks, Matt. Get this fixed. All right, there we go. So tomorrow we are going to Letchworth. If you guys have already signed up, awesome. Make sure you join the workplace event and say that you're going. That way you get notifications for whenever I post announcements and stuff. We are going to be meeting in C Lot tomorrow morning at 9:45. So park there and then walk inside Grace Watson to Beans, because that's where we're all going to be hanging out until we're ready to go. That way we can grab food and whatnot. I'm going to have a case of water and granola bars in case anybody needs anything while we're out there. It's going to be a really good time. We're going to have a lot of fun, and we're going to go hiking. So get hyped for that. And without further ado, on to the news. Oh, it's not mirrored. All right. So sorry, Matt, you posted this in news, and then I didn't see it, and I still included it in the news, so oh well. So basically what happened was a Chinese company that manufactured IoT GPS trackers ended up having a default password of 123456 for all of their devices. And so all of these devices were able to actually be remotely tracked and monitored because that's kind of what they're intended for. But when you have a default password of 123456, anybody can do it instead of just you. So it caused a bit of an issue. It wasn't actually just their device either. They manufactured the same devices for over 30 different companies that just kind of rebadged everything and put it in different packaging. So over 31 different vendors had this same issue of using that as default password, which first of all, you should just never do. And second of all, if you guys ever get any devices, please change all the passwords. Next up, we have some news. 419 million Facebook's users' phone numbers were exposed in a data dump that happened back before Facebook had actually restricted access to that kind of information. So back before the whole Cambridge Analytica scandal, a couple companies collected a whole bunch of information, and they ended up storing it, and it was stored on a server, I think without protected auth, mentions it somewhere. Yeah, an unsecured server. So they held 419 million phone numbers along with some different demographic data on the actual users themselves. So it contained user IDs for the accounts that these numbers were actually linked to. So you could link a number with a person if you could find out their UID on Facebook, and a whole bunch of other different pieces of data.
Is it public?
I'm not sure. I think the server got its hosting pulled once people realized what was going on. And then they just kind of said, oh yeah, oops, our bad. But it wasn't actually Facebook that leaked the data, it was a third party, just like the Cambridge Analytica stuff.
Yeah. So it's something.
Yeah, pretty much. But this can't happen anymore because Facebook stopped giving everybody that information. Oop, that's not the one I wanted. That's next. So there have been a bunch of attacks going around with sending people spam straight into their Google Calendar. So even if an email gets flagged as spam in Gmail, at least before this attack was recognized, people could spend spam out calendar invites, which would just create recurring events every day for the rest of eternity that had spam links in them. So people would get notifications saying, hey, go check out this spam that just happened to be in your calendar. And they would link to malicious sites and stuff like that. And it got all around all of the normal protections that Gmail has for it. And if you go into your Gmail itself and change one of the options, I think it's the one to remove declined events from your calendar, it stops this all from happening. And a bunch of people started figuring this out all at the same time. And the attack kind of died now, but it was really cool to see how a bunch of people just ended up with a crap load of spam in their calendars. Next up, this was a pretty cool article. It talks about how a bunch of schools in the UK, after GDPR happened, went through a bunch of different audits and stuff like that, and they realized that 1 in 5 schools has had students, first of all, smart enough to actually break into their stuff, and second of all, actually break into their stuff. So that was pretty cool to see, aside from the fact that stuff was getting broken into. They had a bunch of other cool statistics in this article that I can't remember off the top of my head. But, oh yeah, so 83% of the other schools 83% of the other schools that were in the survey, or the actual audits, said that they had at least one of the types of security incidents similar to either a student breaching it or the actual attacks that would disrupt the network and prevent people from either doing work or actually doing school things. So that was another kind of interesting thing to see. And then last up for news, I found this article on Security Week, and it talks about how in order to actually facilitate the Stuxnet attack, the US had a, I think it was a Dutch intelligence officer go undercover and help actually get that malware onto the nuclear, yes, that's the word I was looking for, centrifuges to actually stop that or stop them from working properly. And if you're not familiar with Stuxnet, it was a US campaign joint with Israel, I think. I think officially Israel and the US was associated to cripple the Iranian nuclear program back before they were as far as they were. And it was an air-gapped network that people were trying for a really long time to figure out how to jump the air gap, and they eventually used the intelligence officer, and I think something similar to what we do now is just dumping USB drives in parking lots. So kind of cool to see, and I will have these links posted in a little bit. Un momento. So Shannon, you're up first. Do you want this laptop or yours? Okie dokie then. Yeah, man. Okay, cool. Everybody give it up for Shannon.
You'll see. All right, hi, my name is Shannon McHale, and I'm here to present on how I went to a $4,000 conference for free this summer. It's really just me flexing for a little while, so I hope you all, remember how humble I am usually. So, So who am I? I am Lil Prez. I used to be heavily involved in WIC PR, and I worked at the MITRE Corporation this summer. You all probably already know this, but it's a little bit more relevant to this talk than usual. That's a picture of me walking into Black Hat, and there's a rainbow, and I'm all fully hacker geared, so that was pretty cool. So the agenda today, I'm going over the Black Hat briefings, what they are, how I went, and how you can go too, to this conference and many others. So what is Black Hat? It's kind of like a professional DEF CON. If you don't know, in Las Vegas for a whole week, they have Hacker Summer Camp, which is a mix of several conferences together. I only went to Black Hat, although I did have tickets to B-Sides through a friend. There are 20,000 people attending Black Hat every year, 500 speakers, and a lot of companies. They have a really big expo. It's not a career fair. They're not really looking to hire people. They're looking to sell their software to other security engineers, which is kind of a weird thing. But it was a really cool thing. So yeah, so why did I go? This summer I worked on Caldera, which is automated adversary emulation. I'll be giving a talk on that next week if there is availability. You guys should all present instead though, because I don't think you want me up here again. But yeah, so that was really cool, and Black Hat was being presented in the Arsenal section of Black Hat. All of my team was going. I wasn't really like invited to go, but I didn't want to sit in the office alone for a week, so I tried to figure out a way that I could get there. So I sat down and I was like, okay, what do I need? I need $3,000 for a ticket. I need like almost $1,000, maybe $300, we'll see, for traveling, and I need a room. So that's a lot of money. I don't have that money. How do I do it? The ticket I got through the student scholarship. They have 300 student scholarships every year. This was a pretty easy process. All I had to do was talk about 2 talks that I wish I could have gone to. I picked one that was a policy talk from the 90s and said that I wanted to see how war games impacted policy, which was pretty funny if you know that joke. But yeah, and then I picked a more recent one. If you also know any speakers, someone at MITRE was speaking on attack, which is like a pretty cool thing. So they all get 2 speaker passes. I know some people in here have done that in the past. So if you can reach out to a speaker on Twitter and get their student pass, they don't even know they have them until you ask them. So it's pretty cool. So I got my ticket. Ticket's free. Travel's next. What do I do? Skip Lagged is a cool app that makes flights really cheap because it kind of like goes over what the flight direct is. I don't know how it works, but it's really cheap. It's a great way to do it. You might have to fly for like 19 hours, but it's really cheap. And then Southwest, I don't know if anyone's flown Southwest. It is an experience. It is cheap for a reason. They don't even give you a seat. And I'm very tiny, which means I'm always in the middle seat of like 2 very large men somehow. It always works out that way. But so I got like a $300 flight, but I still needed to pay for that. And so what I did was I went up to my boss and said, hey, I have a ticket for Black Hat. I know you didn't invite me, but I'm going. And I also want to go, but I still have to pay for my ticket and my room. Can you help me out with that? And my boss said, of course, we want you to have that opportunity. We don't really have any extra money left over, but we will pay you your normal salary for the week. And you can have that money because you are working at Black Hat, networking, doing security, stuff like that. So I got my usual salary, which did cover the flight. So that's free. Now it's just the room. This is the hardest part. So what I did was I went out to breakfast with my friends who were all WIC alumni. And I said, hey guys, I want to go to Black Hat, just kind of chatting with them. And my friend turned to me and she said, oh my gosh, I'm going to Black Hat. And that was Kirsty. So this is a little flex, little lady flex right there. And so Kirsty graduated way before I got here, but we've kind of kept in touch through networking, through alumni relations and stuff like that. She's a part of the WIC PR legacy, which is what you can see here. Morgan's got some great pants on there. So that's a pretty good way to get a room, is just network, ask around, ask alumni. And so she said, we have to share a bed. I know you don't really like know me, and I was like, that's fine with me, whatever's free. So we shared a bed, and I went that way. So now that's free. And that was it. So then you might be asking, Shannon, did you eat this weekend? did you drink at all? I did not drink because I'm not 21, and there was like quite a few MITRE people there, so I didn't want to be not 21 drinking in front of MITRE people. But if I wanted to, I could have, because Black Hat at about 5 o'clock, happy hour, the expo, instead of having water stations and like muffin stations, has bars. So that's pretty cool if you're into that type of thing or you're over 21. There's also really great parties at Black Hat. So I was able to get a VIP ticket to a really cool lounge, and this is a weak flex because I didn't actually drink at it, but it was the Skyfall Lounge, and I got that through Zach Allen, so I got to cut a very long line of people. If you don't know Zach Allen, he's the red team lead for ISTS. He's a really great guy, a great alumni, contributes a lot. Hey, Zero Fox, please sponsor us. So yeah, I just kind of went up to him. We haven't really interacted before, but he knew I was RITSEC, so he was like, here's a free pass, go through. And so that was pretty good. And then lunch, when you get the student scholarship, you also get lunch for the day. Yeah, so that was it. It was a great summer. It was a good week, good 4 days. I love conferences. That's me going into it. It was one of the most excited pictures I have myself. Meet your alumni, because they're really cool people. They all want to help. They all want to give you the opportunities that maybe they had to give back or that they didn't have because they think everyone should have the fun times. Ask for stuff. Ask your boss throughout the summer for anything you want. Even if you're afraid, the worst they can say is no. They have money. They are a corporation. They got it. Even if it's government, they got a little bit of money in there. And get scholarships. There's a lot of scholarships out there for conferences. It's really easy to get. Sometimes you need a recommendation, but you can usually ask Megan or Stackpole or someone who's super wordy. Yeah, it's really easy, especially for ShmooCon. You guys should all be at ShmooCon this summer. Should you schmooze a student? This winter, this January 30th, be there. Yeah, so it's all gone. But yeah, that's it. Thank you.
All right, thank you, Shannon.
One of you manage the stream to make sure it's.
How do you manage the stream?
Hey Jack, can you do me a favor? I can do it. Oh, never mind. I sent to you on Workplace. I can. You just plug my. I don't want to do that. I got it.
Why?
I'll just share it with you.
I have no idea. Just kind of did that one day, and it kind of pissed me off.
I'm gonna let you give me 1 second. I'm connecting to the internet.
No. Can you pause the stream for 1 sec? Because I'm not going down.
No, you don't have to worry about it. I'm saying I shared it with you.
Okay. That breaks things. All right, cool. Everybody give it up for John.
Alrighty. Can you go hit start recording? Well, let me finagle this mic. Let's put it in my pocket. All right, hello everybody. I'm presenting on my first time. How I got into red teaming and my first experience actually during competition and what it's really like. So, who am I? I'd like to do a lot of offensive stuff and networking. A little over networking after this summer, but it was a good time. I like Windows a lot. I like digging into it and really figuring out all the internals and how everything really works. You can break a lot more stuff than you think if you really start to dig into it. I love development. I love coding. That's how I kind of got my start in security, was coding. I've been coding since high school. It's just a passion I had. And then red teaming, which allowed me to kind of combine all of these. And then some non-nerd stuff. I'm a diver. Yeah, that's kind of about it for that. I go outside sometimes. I like to go outside when it's warm. You know, it's cold like 7 months out of the year here, so it's kind of rough. And then my dog, I like to take him on walks when I'm home and play with him. All right, so my agenda, I'm going to kind of go through me starting off at RIT and like my first introduction to the club, security, and why I actually came to RIT. Then I'm going to get into some blue teaming and how that inspired me to become a red teamer. Then I'm going to get into the red teaming, like how I started with it, what I did to start, and then more what I made. And then I'm going to explain what I got out of it. Alrighty, so starting off in the CSEC program was actually a complete mistake. So I got denied from the CS program, which was pretty cool. But then they put me in the CSEC program. And then I went to a open house, I think it is. And I had an amazing time when I went. We had somebody show the club or the ambassadors, it's kind of all mixed, showed Heartbleed. And I thought that was so cool to be able to actually do an exploit. And it really inspired me to get involved and then actually commit to the school. So when I was finally here, I decided I'm going to religiously go to the club and learn. And that was probably the best decision I've made because I started learning a lot more than CSEC 101 taught me. And it really got me going into actually doing security stuff. So I do want to talk about some mistakes I made freshman year though. My freshman year, I did not get involved nearly as much as I should have. I just went to the club meetings. I tried some like easy challenges and called it a day. I wasn't as active in as much stuff. Towards the spring, I started to do some competitions, but my recommendation is if you're a freshman, you have time, you should do as much as you can to get started because there's a lot out there. Alrighty, now the blue teaming. So why do I think blue teaming is important? It's super important because you get to know the competition and what it's like to be a blue teamer. It really taught me what makes a good experience for blue team. If you're red teaming somebody, you don't want to just keep pelting them over and over and over again. As a blue team, as a beginner, I had no idea red team was even doing stuff to my box, when they were doing stuff and how they were doing it. So the fact that I was like panicking already and I wasn't getting super pelted was a really good experience because I was able to figure it out. And then occasionally the red team would come and help me out because I was newer and I actually got to learn what was going on the box and what they were doing. So that kind of gave me the experience. It gave me the idea of what would be a good experience as a blue teamer, which leads into red teaming. So what made me want to do red teaming was the blue teaming. It was so much fun to actually figure out like, oh, I found something. But I wanted to do it. I actually wanted to exploit it, and it fascinated me how it actually was done. So I figured it'd be really fun. So I wanted to give it a shot. Plus I could code, which was another one of my passions that I didn't really get to use too much except for CS homework. So getting started, I just talked to people. I went and talked to Micah was captain at the time. So I talked to him, and then I asked people for help. And then once I finally got into it, I started Googling stuff, which is valuable. So now I'm going to get into a little bit what I did. This is my one piece of malware I wrote. It's called Autorunboi. So this is what it does. If you're unfamiliar with registries in Windows, there's two registries called run and run once. When a user logs in, it executes every registry key that's in there. So what I did is the highlighted box is the setting and making a key value in the registry. So the H key is like it's the like local machine. It's a bunch of the path for the registry and where everything's located. And then I gave it a bunch of random names, as you see. I kind of just had a random number generator that picked one of the letters in the alphabet, and I had it execute a command prompt. And then it hid. The idea was to kind of hide other people's keys in the midst of all that. And that was kind of my first tool. And it was kind of super basic, and it wasn't too long. It's on my GitHub if you want to look at it. But it taught me something. It doesn't need to be a big tool for you to actually make a difference. This was really annoying during competitions. Anyone who competed knows it was really annoying. And then whenever you restarted your computer, about 100 or to 500 command prompt lines, depending on if you deleted any of them, would pop up on your screen. And you couldn't do anything until they were done, which is also really annoying. So this probably took me the hackathon last spring. I wrote this, and it made a difference for Windows at least. It was a nice little IR report. So and if you're unfamiliar with IR, it's incident response. It was a nice little report that people could write and find and actually catch something. So next was my bigger piece of malware I wrote, which I really, I'd say I learned a lot from this one just because I failed a lot in it, which helped because I learned from my mistakes. So to summarize what it does, it was a Windows service that you couldn't stop, and except unless you deleted the binary or ran malware bytes, but who likes to do that? And it read a registry key, just a random one I made called active, and it was a D word, and a D word's just a number value. So I read it through hex, so it was just 0, 1, 2, 3, 4, and depending on when it read that key, it would tell it what to execute. So the first part of code I want to talk about is this a little bit. So even if you don't understand it, it just opens a registry, reads it, and then right here it shows, it's just checking what the registry key value was. So So whatever it was, it executed. So super simple kind of idea. And I just found this kind of stuff out by playing with the registry and just kind of Googling and thinking about stuff. And then with that, I was able to make messages pop up and explore and trying to think, I forgot all the stuff it did because I added a bunch of stuff and I changed stuff. But the main stuff it did was send messages and explore, which is really annoying because it's kind of scary if a message just kind of pops up on your screen in the middle of competition. And then the next part I did, the highlighted code, I just wanted to put that in there as an example of just playing around with stuff. I had no idea what any of this function did. This whole function reports to Windows whether the service is going to be running, stopped, or pending, or restarting. So what I did is I just kind of dug around and I kind of controlled that for stop, and I found that, and I commented it out. So what that effectively did, without me even Googling anything, was just stop people from being able to stop the service or restart it, which was awesome. It's exactly what I wanted. So just kind of having to have creativity to just kind of poke around and learn what stuff does by trial and error. And here's my last one that I really tried really hard, but it just didn't work for some reason. I don't know why. It worked when I tested it. When I deployed it, it didn't quite work. So I went through the registry again. I really was building off this registry idea, and I replaced all the cursor pictures with this custom cursor, which had the arrow right here and the like actual like mark for it down here. So it was really annoying. Well, it would have been really annoying. And then when you hovered over something, and the dot was still here, but it flipped it down here, and it showed that picture, which is I thought would be hilarious if it worked. I'm going to try to probably make it work this year, but that's kind of what was kind of my failure. But I learned that sometimes you have to develop stuff early and not the day of. So that's cool. So kind of what did I learn from this whole Red Team experience? So what I learned was mistakes are good. You can learn from your mistakes. You should start early though, so if you make a mistake, you have time to fix it. So you're not up till 4 a.m. the night of drinking Monster. I learned how to do research, like actually research stuff. You can't just Google how to make malware and then like expect for it to work. You have to really dig in and like learn what you were trying to do. You can't. So for example, I did registry stuff. I did malicious stuff with registries. Not super malicious, but I used basic functionality to actually do something I wanted to do that was inherently malicious. And then creativity. Having that creativity to think of something different or think of something, how to use something the way it's not intended for. So that's another thing I learned. Sleep is good. Do stuff early so you can sleep. Staying up till 3 or 4 is not fun. Persistence, you want to keep, don't give up on something like this. It took me a long, long time to figure out how a Windows service worked, but you just have to keep at it and you'll eventually get it, and then ask for help. And also teamwork. I learned during the competition, it's very different than what you think it is. We're all sitting there hoping it works, just like you're hoping you can get us out. Or the first timers, I really was hoping it worked. The first competition I had, I got probably booted out of almost every box. But I learned from that, and I also learned you need coordinated attacks with your fellow red team members, because if you all just kind of drop stuff at once, it could get kind of rough for the blue team, or some of your stuff can interfere with other people's stuff. So you really have to work together, talk about what you're going to be putting on people's boxes, and then go from there. That's all I got. Anyone got any questions? Awesome. Thanks, guys. There you go, Jim. Oh, yeah. Thanks. Jim, I'm excited for this.
Can you turn off the display for 1 second while or like just freeze or something? Like, yeah, we
can just unplug.
Because I don't know what's gonna be on it. Well, I do, but
Is it frozen?
it's blacked. I think he's
Yeah.
selected. Yeah.
Yeah, that's good.
Or blank, whatever that says. Oh, nice. Okay.
Yeah.
Do you think that's big enough? I guess we'll see.
You should be fine.
Okay.
You all good, Jim?
Nope. Okay. Hey guys, how's it going? So today I'm going to be talking a little bit about covert communication and more specifically steganography as an example of that. So, okay. Okay. I'm Jim. I do like some blue team stuff, red team tool development. Yeah. Sorry, I forgot to fix that slide. Okay. So great start. So what are covert communications, right? It's the idea that you can send data back and forth without other people knowing that you're doing it. It's something like encryption is good for like hiding what your data is, right? But people are still going to see, oh, you're sending this secure message. The emphasis on covert here is that like people don't even know there's a conversation happening, which can make it obviously harder to snoop on. There's a billion examples for this. Some like ones that we use for red team might include like packing stuff into certain protocols, because there's a lot of unused flags, unused message fields, all that sort of thing. Something that Ian worked on a little bit was some flashing lights as like a visual thing. So you're looking at different colors of flashing bulbs to send messages. Like that's covert channels. It's hard to describe really, because it's basically just any way of communicating that's not recognizable. And one really cool example of this, or I think it's really cool, is steganography, which is about encoding stuff into images. Yeah, so basically like you can hide pretty much anything in a file, right? A picture could be pictures worth 1,000 words, right? Or, I mean, 8 million pixels, like whatever. A picture can have a lot of stuff in it. So like something that might look like a regular picture can have a lot of information crammed into it. And an easy method for this is called least significant bit stego. And so the general idea is, right, like pictures, each pixel, colors have values, right? Like they're just numbers. And if you change like your red value from 255 down to 253, that's like no noticeable shade difference. The naked eye is like not gonna be able to tell that. Like these two reds, those are actually different colors. They're only different by 2 bits though. So even though you can't tell, right, like we have now effectively gotten like 2 bits worth of information. So if you can cram like a few bits into each pixel, right, and an HD picture has like 1 million pixels in it, then that's a lot of data. So what I'm going to be talking mostly about, because it's like what my project is with PNGs. And there's other types of images that have this as well. But more than just RGB, it's got this alpha field, which is opacity. And unless you change it down really low, you can't really see any difference at all. And I made it a little more extreme in the demo so that we can see a difference. But theoretically, you could probably do like 4 bits without really being able to see the difference. And that's 4 bits per pixel, right? So that adds up quick. So like you can change a little more here than you can change with the colors, and that's going to be useful. So just the general idea is that like you make really small changes to this picture, but you make that really small change to every single pixel. So now that I don't know if I'm explaining this well, but generally you can encode stuff. Like it's really easy to put some text into that. That's pretty trivial. Like I showed before, that's ASCII characters. You can just cram bits into it. So actually just message decryption is pretty easy, or decoding. And some other really cool implementations of this is like video, obviously, right? Because videos have 60 frames per second. Like that's a lot of data, right? Or audio is really similar. Audio is also just bits. I mean, it's all just bits, right? So if you change like 1 bit for each bit of audio, like you're not going to be able to hear any difference. But in a 5-minute song, that's going to be a lot of data. So the little thing that I just whipped up like yesterday / this morning is it reads whatever binary file. So rather than trying to hide like strings or messages, we're going to be hiding files, which is potentially useful for like red team is the idea here, where we can put an executable, like we can decode that into base 64, we can hide that base 64 in the image, and then later on we can take it out and execute it. So I don't actually know if this works. It works like trivially, but yeah, exactly. Demos never work. Is this big enough? Can people see this? Sure, bigger? Okay. Okay, so first we've got the image I'm going to use. I'll talk about the weaknesses in a little bit, but one of the big weaknesses is that since I'm only doing a single picture, right, and I have like a lot of data. This is like a 4K image, which takes a long time, right? And it's, because it's a really large image, so it takes a long time to read and write it. So I'd like to transition to video at some point. But this is just like the picture we're going to be encoding to. And we'll do a before and after in a bit so you can actually see the difference. So, nope, not decode. Yikes. Okay, so first actually, we want to look at, what do we want to look at? Oh yeah, so I've got this little implant. This is the thing that we're going to be actually like executing, right? So it's really simple. It's just like a little binary. It's going to like give some output to standard out, and it's going to create some files. So it's a really simple payload. I did that because it's really small. Like it's only a couple megabytes, whereas one of our real implants is going to be like 10 megabytes, and then I would have had to actually implement the video, and that would have been really hard. So we're not doing that. So now we can actually like encode this. I forgot the argument order already. Yeah. So we're going to take our space picture from before. Theoretically, like JPEGs you shouldn't be using because they don't have alpha values, but my program will like add alpha values to them and then turn it into a PNG basically. So you can, yeah, it's a little cheeky, but it gets it done. Okay. Nope, that was wrong. And so the output image, we're going to do a PNG, I guess. Takes a little bit because, like I said, it's a really, really big file. Okay, it shouldn't be taking this long. Something bad's happening. That's great. Here we go. Here we go. Just give it a second. We'll see. We'll see. Okay. Yeah, so that kind of worked. So now, here we go. I don't know if you guys can even, see, I tried to make it like really extreme. Like I'm changing 6 bits, which is a really high number of the alpha value. If we zoom in right here, I guess you guys can't probably see it at all. There's like a color difference line right here, where to the left, it's like a little lighter. You probably, maybe the projector's just not that great. But anyway, like I even tried to make this visible, and it's still not very visible, right? And even that, so 2 megabytes, we used about like 1/3 of the image, I would say. Maybe a little less. So that's the idea. And just to show you in like an actual visible way. So this examiner is just going to look at like a few of the pixels and show us the RGBA values. So if we look at the first like 10 pixels, we can see the RGB values. They're all 255 for the A values. But now if we do this thing that we just created, this hacked space, you can see the RGB values are all the same, but now these A values, whereas before they were all 255, now they're different, right? And those differences, each one of those differences is the order of a base 64 character, which I'll explain in a little bit. So now we've got like this picture, right, that has this executable stashed in it. So, oh yeah, sure, I can do that. Yeah, good call. Yeah, so it's pretty similar actually. Because it went from PNG to, or from JPEG to PNG, so it's a little bigger, I think. I don't actually know. I haven't looked at this. Is that a lot bigger? That's a lot bigger. Yeah. That's substantially bigger. Yeah, okay. Wow, big difference. Okay, big sad. We'll figure that out later. Well, that's just normal file. Yeah. Yeah, so, yeah. Very, very, very true, very true. So now we want to actually decode this, so we're going to look at take it out of our image, and we're going to make our binary. This part takes the longest, I think. Well, guess not. Cool. All right. Yeah, I have robustly tested this. Yes, definitely. So now just to like show what this actually is, I know theoretically this could be a collision, but I just hope not. Now we're gonna, where was it? Yeah, so ignore that garbage in the middle, but these are, so the hash is the same, right? Even we just extracted it from this image, and now if we run it, it does the same thing as that other binary did, where it's gonna drop some crap and it drops some files there. So theoretically, that could actually be used to like do something cool. The part of this that's actually interesting, which I could not get working, I was working on it until I came up here. I can't get it. But it will be there soon. It actually, the idea is, here we'll go back because we got slides on it. So just dropping a binary on the file is like not very cool, or it's not very useful at least, because now, oh, there's just a binary there, like cool, we can put tons of malware places. There's this fantastic syscall that allows you to allocate memory like it's a file. So you get a file pointer to just a block of memory. So yeah, using memfd, you can actually extract that base64 stuff, and rather than writing the file to disk, write the file to memory and then execute it. So that's pretty cool. It was almost working, but not great. And yeah, I really like to do video or like a GIF at least, because that way, GIF. So that way you could, like we could actually put some real implants in it rather than just a 2 megabyte binary or whatever. So yeah, that's it. Anyone have any questions? Probably not. Oh, yeah. I don't know. 5 minutes of Googling told me Golang and MFD was easy. It's not, but it should be. Troy?
Have you seen any like real APTs using this kind of?
Yeah, actually, this was in an old, I had a previous version of this presentation where I mentioned that. This was maybe like 2 years ago. There was this, the campaign was called like Skojo or something. It was this really nice picture of Scarlett Johansson that had a malware implant dropped in the back. And yeah, they dropped that on a lot of things. It was like a couple thousand machines, I think. So, like really daily, is it that effective? No. Is it on the attack framework? No. But like, I think it's cool. All right, thanks.
Thank you, Jim.
Owen? Yeah, so that's the good point is actually, and even knowing when to stop reading is really important. You can put tons of garbage in there, right, and just degrade the entire file rather than only degrading part of the file. But the idea would be that it's not visible at all. I made it really extreme so you could hopefully see it, but I guess you guys couldn't. But yeah, because you don't want people to see like a big color difference or whatever. But yeah, okay. I don't know if that answered your question.
Cool. Thank you, Jim. So I got one more thing to show you guys before we wrap up. Yeah, we're early today. Yeah. Yep.
215 pizza.
Oh, God. All right, so at the end of last year, I talked a lot about getting a wiki set up, and now we finally have the beginnings of our wiki. It's awesome, and we have last week's stuff up already. So this is under RITSEC and then the RITSEC wiki, but if you guys ever come in here, you can go into the archive, fall, and then the meeting day. And we have a whole markdown page dedicated to talking about everything that kind of happened at that meeting. So we outline the research presentations, talk about the challenges, talk about the news, both the actual security clickbaity stuff that I talk about, and then kind of whatever's going around at RITSEC, and later on we're going to have stuff about GSIS and RIT as a whole. And this is going to go up for every single week that we have meetings. So eventually I'm going to have the slide links and stuff in here too, but this is the first iteration of our final wiki. So if you guys ever miss a meeting, or if you're ever on the stream and want to get some more information about what's going on, check it out at github.com/ritsec/ritsec_wiki. Cool. Thanks, Jim. Yeah. Soon, TM. Soon. All right, cool. So yeah, that's everything we had for today, unless anybody else wants to come up and do a fire talk real quick. Yeah, I didn't think so. Yeah, you've got until the fire burns out to finish talking.
Does the fire start before or after you begin talking?
The second you approach the microphone, you just kind of spontaneously combust. Yeah. Cool. All right. Thank you guys. Awesome meeting. See you all next week and around the labs.